Welcome to our InduSoft Web Studio version 7.1 webinar series. This afternoon we're going to be talking about connecting a DCS system to SCADA or an HMI software like InduSoft Web Studio. We're going to show the different possibilities for both connecting and even replacing your DCS system with InduSoft Web Studio solutions. I'm gonna do a presentation about the company and about the product, the different features that InduSoft offers for you to accomplish that goal of connecting a DCS or even replace a DCS system with InduSoft. And then we're gonna have our very special guest, Mr. Patrick Talty from Brookhaven Labs. He's gonna show us how he's applying that solution on his facilities, on his projects. It's a very interesting presentation of a national lab that is using InduSoft in conjunction with a DCS system and talking to several hundreds of I/O points. Welcome, Patrick, to our presentation. So I'm going to start talking about the company InduSoft. We were established in 1997, and since then we've been always on the top of the technology. We were the very first one to offer a complete solution for any human-machine interface or SCADA for Windows CE. Back then you had some other packages running on Windows NT, Windows 3.11, or different versions of Windows, but when Microsoft came with Windows CE, a very small footprint operating system with sometimes 2 megabytes for the entire operating system running out of compact flash. InduSoft was the first one to have a complete package with drivers, with screen presentations, background tasks, alarming, trending, all for Windows CE as well. Okay, and then we were one of the first ones to have a web solution for every size of your application. So you had InduSoft installed on your PC, you develop your screens with just configuring 2 settings. You can have your application deployed over the web and allowing you the integration with XML as well, or using XML to integrate with other systems as well. And we offer also a patented solution for connecting to different databases through ADO, through OLEDB. It doesn't matter in which database that is, so it could be SQL Server, it could be Oracle, it could be residing on remote computers and you're running your InduSoft Web Studio on a Windows CE device. Yes, we still can connect to all those databases, and we still can save data and store and retrieve data from any of these databases. Down here we already have some certifications. We are being Microsoft Gold partners for quite a while now, so that means we have access to all Microsoft tools beforehand. So just as an example, right now we are testing our software running on Windows 8 that is scheduled to come later on the 4th quarter this year, and also Windows Server 2012. We are at ISO 9001-2008 certified company, which means that our quality management system complies with the ISO 9001 requirements. Our certificate is current, and we have the label as powered by Windows Embedded. We've been NoPC Foundation member from its beginning, so way more than 10 years now, and we have the seal of approval of self-testing our OPC solutions, and we are also Motorola and AT&T certified as well. And through the years we've been getting several awards. We got the Frost & Sullivan 2007, 2005. We've been getting Control Engineering Engineers Choice Awards. The latest one we've got was in 2012, which is voted by the readers of the magazine. And we got also Frost & Sullivan 2010, wrote HMI software, and the Global Web-Based Human-Machine Interface Customer Value Enhancement Award. So we are very proud that we are achieving those things, and a lot of that is because users like you guys have been helping us to achieve all that. So I'm going to talk a little bit about the advantages of the InduSoft Web Studio solution to achieve that I'm sorry, to achieve the solution of connecting to DCS systems. So the first thing you need to have in mind when using a solution like this is, okay, how am I going to connect to the I/O fields out there? A DCS system should be able to talk to thousands of I/Os. So you have your plant down there, you have your sensors, everything talking to different PLCs, different or different controllers. So on this chart here, I'm going to start talking about this one here on the bottom. InduSoft Web Studio offers you about 240 different communication drivers, speaking several different protocols as part of the product. So with that, I mean, if in your plant you're running for the control part PLC that speaks Modbus, InduSoft has native Modbus drivers for all the different Modbus flavors, RTU, ASCII, serial, Ethernet, Modbus Plus as part of the product. Okay, if instead you have Siemens, we have the drivers for Siemens S5 or the S7 family, 200 all the way to 400, and even the new ones, 1200. We have the drivers for that as well. All the unbranded families, it goes back all the way from PLC2 to PLC5 to the Control Logics family. And we can talk Ethernet, we can talk serial, we can talk DH+, to all these unbranded families. And the interesting thing is that this is all part of the InduSoft Web Studio product. Don't need to go and install any extra to be able to have the communication with all those devices. Okay? And in some cases, you may want to use the OPC communication instead of our native drivers. You may have a device that the manufacturer provides an OPC server as part of its solution, and we can communicate OPC in all the different OPC specifications. So with me offering OPC DA, only spec 2.05, since always, and now with the version 7, we added OPC Unified Architecture or OPC UA at OPC.NET. And later on the source spec 1, we added also the XML connectivity and support to the 8.3.0. So our OPC solution is very complete. Even for Windows CE, you have OPC DA, you have OPC UA as well now on version 7.1. Okay, so you can communicate with the devices using one of our native drivers. You can communicate using one of our different OPC solutions. And if you need to have access to our text database or to write your own communication driver, we do offer the APIs and the toolkits for you. Let's say that you're writing your own program using Visual Studio, using C++, C#, Visual Basic, and you need to have access to the InduSoft information. We do offer the tools to do that, so you can get the driver toolkit, write your own driver, or if you're writing your own application, you can access through a DLL or ActiveX our tag values, our tag fields, all this type of things. All right, so you've got the data from the fields, and you got the values from the tags. Now you may need to have access to a database to store the data that you are acquiring from the field. So we offer different ways to access the database, but basically access to any relational database. That would be through ADO or ODB, it could be through ODBC, and even the legacy DDE system, you still can do that. And we also offer gateways to connecting to other SCADA systems natively. So that means you don't need to change anything on that other SCADA to communicate with InduSoft. We provide a way to communicate different InduSoft applications through Ethernet, through TCP/IP. That's our TCP/IP task. And we even offer an OPC server as part of the package, a DA server. And that's very interesting because I've worked on systems where the DCS system actually is an OPC client of our SCADA. So we talk to the PLC, we acquire the data from the PLC using the drivers, and then we make that data available to the OPC servers, to actually through our OPC server to OPC clients. In that case, a DCS is the OPC client. Okay, and everything that you configure is web ready. We can deploy that information, you can have that visualization using Internet Explorer and see all your screens, or using our mobile access on iPhones, on Android phones, tablets, using our mobile access solution based now on HTML5 that just came out with our version 7.1. I'm going to talk a little bit about that later. So as part of the InduSoft solution to allow you to integrate with DCS system, we offer some OPC servers from Metricon, and more specifically the OPC server for DCS. So you see here connection to Foxborough, to Yokogawa, even to ABB, to Honeywell. You got the TDC 3000 or the Experience. So we have the OPC server to talk to all this different DCS systems that we can resell in our partnership with Metricon. Okay, and that as part of the package, we can also offer you standard OPC servers for some specific protocols like Loanworks or JC N1 and N2, and some other OPC servers even that we have the drivers for them, but you may have more options with the OPC server if you want, right? From DNP3 or IC6870, we have the driver for the 104, but you may want to use OPC instead, so you can get that through a Metricon. Same thing about Modbus. Okay, so once we acquire the data from the fields, either using OPC or using the drivers, you may want to store the data, that data history on a relational database. So that's where you can use our patent database interface that allows you to connect to any relational database. Could be SQL Server, could be Oracle, could be MySQL, in a very transparent way. So if you need to change from database A into database B, it's very simple to do that. We have a native interface to do that, and it has built-in redundancy in 2 different flavors. You can have a full redundancy, so every data that comes, every alarm that happens, every event, you can put them on 2 databases at the same time. Or you can do the storing forward. Let's say we are acquiring the data and the primary database goes down, we are through a network and the network goes down. I can do a storing forward, so saving the data locally on my PC, for example, and when the primary database comes back up, then we're gonna synchronize both databases, send the information that was stored to the primary database, and having all the information in just the central database. And you can do that for the alarm history, for events history, trending, and any process data. So with that information on the database, you can go ahead and build your OEE, or overall equipment efficiency dashboards, and much more. Okay, and that interface goes through standard technologies. We use ADO, we use ODB, ADO.NET, ODBC, so native connections for database. So we got the data from the field, we are storing the data on the database. Now we're gonna present this data. So on this slide here, we're gonna show the different options you have to present that data out. So starting on this level down here, you could be running InduSoft Web Studio on a server computer, so that would be your bigger application talking to all the IOs. But you could also be running InduSoft Web Studio as a local HMI, let's say a PC panel, okay, or one of this type of headless devices. Here you have ICP, that's WinCon. You have a backup CX system here. You have the advanced Uno system here. So you could be running on one of these guys. They run embedded operating systems. Could be Windows Embedded CE or Embedded Compact. Could be Windows CE 6, Windows Mobile, any of those. Or a control room, with an application, thousands of tags, talking to all the PLCs and all the databases and everything. So you could be running the product or the project in any of this type of devices or architectures, and then you can deploy this data, and the data can be seen by WebThing clients through the network. So you can open Internet Explorer session and have access to all the screens, all the trending, all the alarm information, everything through a browser. Okay, or you could have dedicated secure viewers. That would be our product called InduSoft Web Studio Secure Viewer or InduSoft Secure Viewer. Thin clients that will basically be a remote visualization tool. So everything will be happening on one of these machines here, and you'll be seeing the screens, you know, and the alarms and the trending, all the history you will be retrieving using a remote viewer like this, okay? And also you can have access through our mobile access solution to tag values, to alarm information, and now also to trend charts. If you're using a mobile device or a tablet, doesn't even need to be Microsoft based. So we've been tested this several different architectures, you know, with iPad, Android, even Apple OS 10, Safari, any browser that supports HTML5, you would be able to get information from a project running in any of these architectures here, including, as we go up here, if you're running your project on a cloud. So let's say that you rented a cloud computer, you're deploying your project there, so you can have access through one of these client options from a project running even on a cloud system like this. And that gives you a very interesting solution using InduSoft Web Studio, that you're not tied up to a specific hardware vendor. You could run InduSoft in any Windows operating system, so it goes all the way down from Windows Compact to Windows Server 2008. Of course, depending on the size of your project, you should pick the appropriate operating system, but it's just one product, which is InduSoft Web Studio, to run and build applications to any size of projects. Okay, you see what you see here on this slide are screens from actual projects, okay, not demo applications. Those are, you know, customers that sends us their screens and allowed us to show them on the presentation, with, you know, running on mobile, running on panel PCs, and running on server computers for OEE and MES systems. Okay, so I'm gonna discuss quickly here a typical architecture where you'd be using InduSoft Web Studio. So in this case, let's say that you have down here a DCS system, and we are going to be communicating with this DCS system from a local HMI, from a local PC, from, you know, a local computer, and all the data that we are acquiring from here, we are storing on a database here on the left. So let's say that that's my local HMI, and then I'm going to connect a secure viewer thin client for that will be almost that's basically a secondary viewer from this machine. So this secure viewer will not be talking to my controllers, to my PLC, not even talking directly to the database, but actually talking to my local HMI that is acting as a server. Okay, and from that server can also serve that data to you on my intranet, to web thin clients. So you have someone on the management room, and they can open the browser and see the screens, see reports, see your trending information, or get some specific information using our mobile access thin client solutions, again based on HTML5. But you can also go through, let's say, through a firewall, and go through the firewall using our web tunneling gateway solution to a cloud-based server. So you have a cloud connected to your local HMI, and then from any part of the world you're seeing through a web thin client, through any Internet Explorer, or using any other system to access our mobile access thin client solution. So from anywhere in the world, you could be seeing what's happening on this machine, on this plant down here. And the nice thing, all that using just one product, which is InduSoft Web Studio, and this is all part of the package. There's nothing extra that you need to add for all this to happen. Okay, so I want to now introduce you guys to our very special guest, Mr. Patrick Talty from Brookhaven, and I'm gonna welcome Patrick to our presentation.
Hello, Andre. Hello, everyone.
And you're the presenter now.
Okay. Let me just share my desktop. Give that a moment to go through. Okay. It looks like we are online now. Thank you very much, Andre. Well, as everybody has heard, InduSoft offers a comprehensive solution. And I hope what I can show you today with my project here as an example is how that works in the real world. So what we've done is we've taken InduSoft Web Studio and we have integrated it with a crisp DCS system. And I wanted to start off by giving you a little bit of history of the laboratory where this project resides. The name of the laboratory, as Andre mentioned, is Brookhaven National Laboratory, where we are located in Long Island, New York. And the lab has been operating for about 65 years, and they've garnered 7 Nobel Prizes over the course of those 6.5 decades. The picture that you're looking at before you is the relativistic heavy ion collider. The ring that you see there is 2.4 miles in circumference, and that is the atom smasher, the particle accelerator. Basically, there are two loops, 2 rings, and particles are accelerated, stored, and collided at various points, intersecting regions around that ring. And the results of those collisions are investigated by sophisticated detectors, and the scientists do their science that way. The role of the project that I'm involved in specifically is the cryogenic plant. By the way, this is the Rick ring. They're highlighted in the box as seen from space. A little novelty I thought I'd throw in. The cryogenic plant is we don't make a product. We don't make widgets. So it's difficult to track productivity as a function of things we've made and how many we've produced successfully and sold. Our job is to make helium cold and to keep these superconducting magnets in this 2.4 mile ring cold. So in that respect, we're kind of like a utility electricity generating plant, for example. But our commodity is not electricity. It's the service of making the superconducting magnets cold. There's a couple things here that you can take a look at. I'm not going to read through all of them because I'd like to spend a little bit more time in the latter part of the presentation. But you can come back to this once they post it online and read some of the fun facts. One thing I will mention is that our cryogenic plant uses 5 megawatts of electricity, which is enough to power about 5,000 homes. So it uses a lot of power. And this is a simplified schematic of the entire process. The ring obviously is down here, the rings I should say, and the cryogenic plant is basically everything outside that. The best simplistic example, an analogy that I could make for the operation of a cryogenic plant is if you think in very simple terms of a can of compressed air. When it's full and at room temperature, if you hold it in your hand and you open the valve, you squeeze the trigger, and the contents, the compressed air, leave that can. You have a constant volume container, the can that's undergoing a rapid depressurization, and as it undergoes that depressurization, there is a corresponding drop in temperature. And in very simple terms, you can think of this the same way. We have the compressor system up here. That's where the electrical power is consumed. So the helium gas is compressed, and then it is expanded. And as it undergoes this drop in pressurization, again, it undergoes a drop in temperature. As the gas gets colder, we kind of bootstrap on that, and we take the cold gas and make it even colder. And that's how we go from room temperature down to negative 450 degrees Fahrenheit, which is the critical temperature that's necessary to achieve superconductivity. of the magnets. And these magnets, not unlike the magnets in an MRI machine, are used to, in this application, are used to steer and focus the particle beams. Okay, and this is some of the hardware, industrial hardware that's used to accomplish this. The cryo plant has an interesting history. It was originally built during the late 70s and early 80s for a particle accelerator that was never actually built, called Isabel. There were some technical problems, and the cryo plant was built and commissioned. It was at this point that the CRISP DCS system, with approximately 2,000 I/O points, was installed for the cryo plant. When the Isabel project was canceled, the cryo plant was mothballed, and it wasn't until 1991 when the Department of Energy gave approval to build RIC, the relativistic heavy ion collider, that this system was brought back to life. And at that time, they Square D, which I think is a name most people are familiar with, was the owner of CRISP Automation Systems at the time, the people who made the DCS that we already had. So Square D PLCs were installed around the RIC ring, and that added a significant amount of I/O, about 10,000 I/O points, probably a 50-50 mixture between floating point, analog stuff, and digital values. Construction finished, and RIC began operations in calendar year 2000. So we had this brand new particle accelerator with a lot of excitement around it, but the cryo plant, in many cases, had equipment in it that was 10 to 15 or even more years old. So right from the beginning, there was an effort underway to upgrade. The picture you see there is one of the VAXs running a VMS operating system that was used to host the original CRISP DCS. So upgrades, of course, are incremental based on funding, resource availability to actually do the work, and time to get the work done. And we took, there was dumb I/O that actually ran the cryogenic plant. All of the logic was done in the DCS, and the I/O was just responding to commands from the DCS. There was no intelligence, no way to program it at all. So that was the first stuff to come out, and we replaced it with high-integrity PLCs from RTP Corporation, which had a phenomenal amount of redundancy that we still enjoy today. The next thing the next item that was upgraded was the DCS itself. It runs multiple programs, as you can see I've listed here: process control, of course, data acquisition to bring all of the I/O in and out, flow calculations. There's a Fortran program that does some interesting flow calculations for the cold helium, and it amounts to tens of thousands of lines of code that was developed over many, many years. Very robust, and it was not really, there was no thrust behind trying to rehost it onto a different platform. So a systems integrator that we worked with very successfully over the years, Salem Automation, down in North Carolina, helped us rehost that onto a pair of redundant alpha servers. Very smooth cutover, and that's been working fantastic to this day. So now that we had the I/O in good shape, the DCS in good shape, we had to turn our attention to the user interface. And the user interface that came with this CRISP DCS was tightly integrated to it, which meant it too was old. It was a DOS program, 8-bit bitmapped graphics, and it was running on 10-year-old Digital Equipment Corporation PCs. And it was a large application, about 500 screens. Those, obsolete product, no longer under development from the original manufacturer. and running on obsolete hardware. So we went and examined our options. One option was to take the DOS solution and essentially run it on an emulation platform. Again, you can go through this at a later time, but basically, in a nutshell, it meant kind of rehosting this DOS product in an emulation that ran in an InduSoft shell. Advantages is that it was quick. You could get off the DOS operating system and onto a Windows platform. However, the drawback and ultimately what made this not a good option for us was that the development tools for making changes to the screen did not function in that emulation environment. So if you had a project that was not going to change at all, if you had a plant that was commissioned and set up for like a pharmaceutical manufacturing process, maybe that's a good idea. But for us, where we knew we were going to be making significant changes, it was not a viable option. Would have been nice because it was, a quick and easy way to do it, but ultimately it was not practical. So that leaves us with just really one other option, which is to kind of go back and reinvent the wheel, which we did. But we were able to make a better wheel, a much better wheel. So the list that I have here, and I make a point of noting that it's not exhaustive, and I list the factors here that led to our decision to use InduSoft over some of the other offerings that are out there. One was a recommendation of our systems integrator that carried a lot of weight. I didn't put it in this list, and I should have, but certainly the price was a big consideration as well. And again, there's a number of things here. I'll just kind of touch on a couple. The availability, and this to me is really a defining element in the suitability of a SCADA product to be integrated with a DCS, and that is the ability to have the two systems communicate with one another. If you don't have robust, high throughput communications, then anything else that you might want to do is really for naught, because they need to be able to communicate seamlessly. And there was a fair amount of effort spent early on to demonstrate that the SCADA product, InduSoft, could communicate with the DCS. And there was a number of things that were done. Our initial testing demonstrated that the communication throughput from InduSoft to CRISP would allow us to read or read-write 8,500 tags per second, which is really good throughput, and that's certainly suitable for a great number of systems. But our DCS system has about between the multiple databases that run on it is about 65,000 tags. Not all of those necessarily have to be brought into the SCADA. A number of them are just internal tags, but the vast majority of them do. And our InduSoft application today has roughly 47,000 tags. And most of them, not all of them, but probably about 40,000 of those come from the DCS. Now, with that being said, we have to understand that with those 40,000 tags, not all of them have to be brought in every second. Some of them do. Stuff that's in the cryogenic plant where things can change very quickly. Certainly, we require a fast update rate, and we achieve that easily. Other things like temperatures in the RIP ring, the time constants are very long. So in that case, we update them once every 4 seconds. But a number of things were done by InduSoft. One that I'll mention is the simultaneous request feature, which is something that would be of interest to somebody looking to do a large number of communication requests. And basically what that does is it allows a single instance of a driver to run in a multi-threaded way, rather than just, making a request between the SCADA and the host. You would make 2, 3, 4, depending on what the protocol and what the process control network can handle. It is deterministic, or it is determined by the particular situation. But it did allow us to take that 8,500 tag per second throughput and multiply that by a factor of 4 for sustained throughput. You could even go higher than that, depending on, again, what the operational conditions are. But it really kind of made a very strong statement that this is a product that had very, very fast data handling routines, and it would run on reasonable hardware. I didn't have to go out and buy $7,000 servers to run InduSoft. I'm pretty cheap, so I run it on Dell Optiplexes. The servers that we use are typically with 2 gig, or for my 64-bit machines, 4 gig of RAM. So usually like 3 gig processors, dual core. Newer stuff is quad core, but not very demanding really, and not very expensive. I'll let you come back and at your leisure look at the other things, the text messaging and alarming, and I'll move on a little bit more. The BIC client, WebFin client, Secure Viewer clients, and the Studio Mobile Access that Andre spent some time on, we use them all, and it's given us a flexibility to operate the plant, visualize what's going on from wherever we are, whether that is here on campus, at home, on vacation, sadly, and it really has given us a tremendous amount of freedom to kind of live our lives the way we need to live them, while still making sure that the business that needs to be done here gets done. So it's given us a tremendous amount of flexibility as to how we do business. Again, come back to these slides and learn a little bit more about why we ended up going with InduSoft. This is a simplified. I'm just trying to be mindful of time. It's not that I want to blow through them, but there's just so much to talk about. So this is a very simplified architectural view of how our system is laid out. Right in the center, there's a rack, and on the shelf up top there, the 2 Dell Optiplex 960s, Windows 7 32-bit, and that is, as you can see, those are 16 WebFin clients and 16 Secure Viewer clients and 4 Mobile Access clients. And they're all times 2 because we have 2 servers. So technically we could have 16 WebFin clients connected here, and load balancing 16 connected here. So plenty of capacity for thin clients through multiple firewalls and down here, and that's all right. So this is all operator facing on this side, and down below is the DCS. It's the 2 HP Alpha servers, also arranged in a redundant fashion. And you can see here I have some dotted lines. That's the external network, if you will, that we can publish data out on for viewing by our credentialed customers. And then the solid lines are to indicate our process control network. Obviously, an ultra simplified view, but it shows that they're, although this process control network is separate, it's not routable. You can't get to it from the internet. By the use of non and publish it up here. And we've been doing this for just about 10 years now. Not redundant, but the redundancy we just added a year ago. So this is the original control room, which is the thick clients, meaning those workstations have, the hard key installed, and the communication drivers hit directly on the CRISP DCS to get all their data. We added a second control room just last summer, and I did this with a pure secure viewer solution. So all of these workstations, and there's 5 workstations exclusive of the laptop that's installed in the center. But the CRISP DCS doesn't see those at all. They present no load whatsoever to the CRISP DCS. Its database access servers, the process control network, at all. Everything here hits on the InduSoft servers, the redundant InduSoft servers. So when I have to take one of these servers down for maintenance reboot, the clients here switch over automatically. And the first couple times I did it with staff on the phone, and they were oblivious to the switchover. So I've done that many times back and forth, and it performs as advertised. There's also other secure viewer stations, multiple ones, installed elsewhere around the facility. And like this control room, they hit on the servers, not on the DCS. So it makes life easier for the DCS. It can just do its process control stuff, and all of the operations-facing work is done by the InduSoft servers. Okay. Now we start to get into things that capabilities that InduSoft gave us that the old HMI, and it was just a human-machine interface. Now we start getting into the things that really made it cool to use and made our lives better in the process. So this is my BlackBerry Torch, and it shows me out in the parking lot looking at what's going on in our system, which we just entered shutdown. So you can see our compressor power is down at 0. So we're not doing much of anything. But just by looking at a couple of those system parameters, I can get a quick appraisal of what our system is doing, good or bad, and usually it's good. This is one of those remote secure viewer workstations that we have distributed around our campus. Nothing special. It's just a small, ultra small form factor Dell Optiplex. I think the monitor and the CPU was like $1,000. There's no license on this because it's a thin client that resides on the server. So it's very lightweight, very little software that gets installed on it. And the thing will probably last 20 years, I hope. This is the iPad, the original iPad 1, just Wi-Fi only, 16 gig, through a credentialed VPN connection onto our lab network, and using remote desktop protocol. I'm looking at the server that I'm talking to you right now from, as a matter of fact. So it's pretty neat to see that really is the first viable tablet ever made. Like, you can run this on it. So it gets me pretty excited to know what things will be like in 5 or 10 years. My kids don't like me using their iPad that much, though, so I'll have to get my own eventually. Okay, this is a bigger picture of our original control room. This is an actual photograph of the sketch I showed you before. Again, these are my $1,500 each Dell Optiplexes, and these are the more expensive HP Alpha servers running the CRISP DCS software. This is the screen rendered by the old DOS program. Actually quite good for what could be done with the product at the time. And this is the new control room that we just finished using for this last physics There are 5 workstations here. You got 1, 2, 3, 4. Those are all dual-headed workstations, so you can open screens on the left or the right monitor and move things around. And then the 5th workstation actually has 2 dual video cards, so it's a quad display, and it worked phenomenally. I wasn't sure how it was going to work. I bought the stuff without knowing, but it scaled up as easy with 4 monitors as it did from 1 to 2. So these are kind of comfort displays, so anything that the operator wants to keep an eye on, they can throw it up here very easily. There's 1 mouse and keyboard right here, and through the use of a product called Synergy, which is free, Windows as well as Linux distributions, they can actually control all of the monitors that you see here from the 1 mouse and keyboard. Because there is just 1 person manning this console here, or if they want, they can pull the keyboards out if multiple people were going to work. So it goes both ways. One thing I do want to point out is the cost to build this room, the hardware, monitors, computers, and the software, which I'm defining that as the purchase of an additional InduSoft server and the license for that, was about $30,000. The original, DOS workstation that was used, the single head one in 1980, was $16,000. So that kind of speaks for itself. I believe the furniture here probably cost as much as the SCADA control room. Okay, so that concludes the presentation, and I wanted to move through that kind of quickly, and I apologize if me doing that was a little frustrating for you, but I wanted to go into the live system just to kind of show you, what it actually looks like. To me, I always find that most interesting when I can see how other people do things. The red flashing means that there's pending alarms that are occurring on those systems. This is the compressor building, that pressurizes the helium gas. I mentioned that historical trending is of paramount importance to us because we have so many pressures, temperatures, flows, liquid levels that we monitor. Trending is an invaluable way to not only evaluate how things are going, but are very useful for troubleshooting when things go wrong. Excuse me 1 moment. Okay, and trending takes two. We kind of do it 2 different ways. One is a quick little pop-up trend that we have here, and let me go over here. This is the outside temperature right now, and all I have to do is point my mouse to it, and I can take this, and we'll go out to 4 hours. Let's go out to say 96 hours, and that pulls in really quick. So you can see the rise and fall of temperature during the day and during the night, and I can lock that in. I can bump this up from 1 channel to 2 channels, and then when I hover over another variable, I just hit my escape key and I load that 2nd channel. So you can see that the gas pressure in these tanks obviously rises and falls as the ambient temperature around them rises and falls. So that's kind of a neat little tool that is used really constantly. I'll go back to 1 channel and unlock this, and you can see how quick how fast I'm pulling that data out. I use 10,000 RPM Western Digital Velociraptors. I swear by them. I think it's the best hard drive made. At this point, I would still choose it over solid-state drive. I am on the server pulling this in, but the client the WebSyn client or the Secure Viewer client performance is not all that much different than what I'm experiencing here. Again, that's 4 days worth. So now that's 8 days worth. And I just pulled that up in like 2 seconds. So this is really used constantly. This is something that our old DCS interface didn't have. All of the trends had to be hard-coded, including the limits. So to have, the ability to basically trend everything, and that's 3,000 process variables that we trend, if I didn't mention that, is invaluable, because you really get a great idea of not only what's going on, but maybe what happened a week ago, or a month ago, or 2 years ago. We have several years worth of data that's online, because hard drives are so cheap. The 300 gig Velociraptor, I think, is like $200 or less. If we want to get a little bit fancier, we have this, a little bit more of a full disclosure trending, and I just have a couple of variables that are pulled up here. And this is something, again, you can control. If you've used the trend control object before, you know how flexible it is. But this just allows you to, compare multiple channels against one another, not just one or two. One other thing that I should mention about this is there is an application extension, a DLL, that's included, and it allows you to do numerical data retrieval. So you have this, trend here, which is nice. But if somebody wants to get that data out of the system, this interface allows them to do that, and they can select what resolution they want every 15 seconds, which is how often we store the data. If they want it for, if I do 16 hours, right, and I do it once an hour, that's going to be 16 samples. So let's go every 5 minutes. That's 192 samples. So I retrieve the data, and that DLL runs through the history files. It extracts that tag for me, and then I can open that data in Excel or just as a text file. And here it is time-stamped, right, the day, the time, and then the value. And then you can go in, right, and you can parse this out and calculate to your heart's desire. So that's a way to actually get information to the system. We couldn't do that with the old DCS system. I'll close this. Communications, and I could go on and on, but I spent a lot of time talking about communications before. What this page shows is the status of the communication transfers that are performed between the InduSoft SCADA system and the CRISP DCS. Up here in the top, the two async right here, this is the simultaneous request, which means that this driver, the things in this blue box, are running in a multi-threaded mode. So it allows us to make sure that we get all the data in a timely fashion on a regular basis. The stuff that we only need like every 4 seconds over here, you'll see that this will update. This will be 25. This is the seconds count right here. This is just part of it. There's more. This is PLC, same thing, but for a PLC driver that InduSoft wrote for us, and then modified in both cases for free. And this is some more stuff. Again, this updates every 4 seconds. Now, you look at this, and each one of these lines that you see here, let's go way up at the top right here, this represents up to 256 variables. So if you look at how many are here, you can just see that every second we're pulling in, thousands of tags. And we do this on the server because we never know what pages a client might be looking at. You could determine that, but we just refresh these on a regular basis. The database access server on the DCS has no problem with that. We spent a lot of time to optimize these transfers, and it's been working out phenomenally for us. On the thick client workstations that we have in our original control room, if you're keeping up with me, those do not read all the time. You see this read while open. Those only read these tags when the page that these tags appear on is open. So we're able to kind of, optimize the communication transfers on a workstation by workstation basis, based on what the requirements of that system are. There's an unlimited amount of flexibility that you have in triggering these driver sheets, and you can do whatever you need to do to make it work for your system. What else? It's just about our hour's almost up already, which is amazing. So I can pass this back to Andre. This I'll just mention one more thing. This XY graph here. This is the temperature of the particle accelerator ring, and this is showing the current temperatures in Kelvin. So around 300 Kelvin around here is room temperature. So you can see this area of it has been warmed up to room temperature. This stuff is still pretty cold, down at 80, 90 Kelvin. But I use recipes to actually animate this and record a couple days worth of activity. So you can see it slowly rising. And people do pay attention to this to kind of get a feel for, what the rate of rise is and how long it's going to take things to warm up once we do shut down. So there's an example of an easy use of recipes to reflect some data very, very nicely. Okay, so I can go on, but I think I'll end up. This is just PLC status. We monitor power supplies, card status, redundant transducers, that kind of thing. So, it's comprehensive, like Andre was alluding to in his presentation. I hope I've demonstrated that to you. If you've, haven't used InduSoft or haven't thought of using it for, a project of this scale, here's an example that demonstrates that it's not only possible, but you can achieve some phenomenal results in doing so. So I highly encourage you to investigate that. Can I turn this back over to you, Andre?
All right, Patrick. That was really amazing. I really appreciate that.
Sure. You know what? Can I take another 30 seconds?
Of course. You want?
Sure. Let me just point out the database integration. It was last year that I did the first application of database. The staff here, whenever they perform a job, would have to go and enter data into a Microsoft Access database, kind of a clumsy interface, and it was only installed on a couple machines. And what I did is I saw there's an opportunity to redo the front end of that in InduSoft, and these are all with .NET controls, and using the ADO connection, I was able to first of all pull all the data that we had stored the old way, and redo that in a modern interface that's easy to use, that's ubiquitous around the campus, so people can get to it anywhere, and it's better. They can search for stuff a lot more easily than they could before. So they can look for PLC, and we run a SQL query, and there's 70 records that match that, and that was all done with the InduSoft product. There was nothing additional to add on. The database that we're connected to is actually mounted up on a different server that gets backed up automatically every night. So I don't even have to, once I created it, I really don't have to do anything with it beyond that. So something that I wouldn't have thought to do without the feature that is natively part of InduSoft. So that's it. I just wanted to mention that real quick, because that's a really cool feature of the product, and I'm sure I'm going to be using that for other applications as well. Okay.
All right, Patrick.
Take that away, Andre.
All right. Hey, thanks again for also pointing the database connectivity. That's one of our very strong tools. You've used that. You saw that it's not that difficult to configure, and you get good results out of that, and it's also very reliable. So,
yes.
After this great presentation where Patrick showed how you can use InduSoft products on a very large project, communicate with hundreds of IOs using Ethernet and bringing this data in and connecting to the database and creating very sophisticated trend charts, even trend XY. I would like also to mention that we were on the few products that you can have also vertical trends besides the horizontal trend. So if your solution would need something like this, you could use InduSoft Web Studio for that. And now we're gonna go to our Q&A session. You guys could open your panel there and write your questions depending on the question. We may be able to answer and have everybody sharing the answer. So just go ahead and open your Q&A panels. And gonna be either me or we can have our guest Patrick Talty answering the questions as well.
As I said earlier, Andre, no questions means we either did really, really well or really, really poorly.
Yes.
I hope it's the former and not the latter.
Well, you did really great, Patrick. It's very interesting the way you apply and all the different tools that you use. I think it would be worth to mention to the users that are still online that Patrick is being a long time customer of InduSoft, or not only Patrick, Brookhaven, but through Patrick, he started using InduSoft on the version 3. We evolved all the way to version 7.1 now, so he saw us adding functionalities. He knew when we were limited to our built-in language and math worksheets, and after that we introduced the VB script, very powerful trend object, the connectivity to the database, and how quickly we improved the existing drivers or we created new communication drivers. So I'd like to mention this longevity, sorry for the accent, that is very important for the existence of our company. Okay, we got a couple of questions.
If I could add one thing to that,
yes.
Just to make your point. We did start this back in version 3, and we're currently sitting at version 7.0. And through each of the upgrades, we've never had to modify. This is important. We've never had to modify the application to, work around an issue that we came across in a version-to-version upgrade. They've maintained backwards compatibility. For example, any of the scripting that we did with the built-in language worked 10 years ago, and it still works today. Much of that has been converted over to VB script, but of course anything new that we do with VB script. But it doesn't require you to go through and refactor your application if you do choose to carry it up to a new version. I know for a fact that that's not the experience that other people have had with competing projects. So I'm glad you mentioned that, because that is a great point.
Yes. So we got a couple of questions here. Some of them are interesting that we could answer to everybody. So we've got one customer here asking, saying that he's interested on the formal training or InduSoft Web Studio here in our headquarters in Austin, Texas. If you go to our website, InduSoft.com, on this next slide here, we show that. So if you go to InduSoft.com, you're gonna see the educational link there, and there you will be able to see all the dates for our training. It's a 5 days training. Here we have a specific link for the training. Those are the dates that we have for 2012. Okay, and all the information for the training, you need that. You can send an email to training@indusoft.com. okay, and we have one question asking if we could do an overview of the communication driver. We even have just before answering that, this webinar is being recorded, and you will all receive an email when this will be available for you to watch that again. You can watch as many times as you want. And we even have we had a couple of months ago a webinar specifically about communication drivers, so you're more than welcome to watch that one. Show some examples how to connect to some different PLCs back then. So we have videos for the drivers as well. So I believe that would be way more informative than if I go only a few seconds here to show the driver. But basically what you do on the driver is that you associate an InduSoft Web Studio tag to a PLC address. If the PLC supports let's say a memory access type, that's what we're gonna access. So here you guys can see my Web Studio. So I go here on the communication drivers, I can add different drivers. So here I'm talking to that Omron PLC, or I could be talking to Allen Bradley PLCs, Control Logic, Siemens, all these different PLCs, or as you call the RTP, for the 2300 that Patrick was talking about. That's the one that they use. And if I pick, I don't know, for instance, one that is widely used in Europe and South America, if I take the Siemens driver, I associate one tag. So let's say that I have my temperature, and the temperature is a real tag, and that one goes to the PLC with the IP 192.168.0.99, for example. And I'm gonna go on my input word 11, for instance. I'm gonna read that as a floating point, so I put an F on it, or IF. Is that pretty much what I do? So we treat that as floating point. If I put a W, that's gonna be a word. Or if I'm going to a DB, I put, for instance, I'm going to my DB10 dot double word 11, for instance. So use basically the same syntax as used on the PLC. So tag, station, I address, read and write, scan when zoning on the screen, always, or whenever we find the tag that we read, let's say on scripts or things like that. Okay, but you can get way more information on one of those videos that I mentioned. You can go to our website, and on our website here under the solutions on support, we have all the videos and webinars, so you can have access to all of our past webinars. So you got OPC, we got the drivers somewhere down here, I believe. If I look more carefully, I should be able to see it. Driver configuration. I know it's somewhere here. But we even have our YouTube channel that you can watch that. I got a question here that most DCS systems have faceplates to control and show status of common equipment, of process like PID, loop, etc. If we have faceplates functionalities, actually you can build the faceplates and reuse them. We have several customers that they use this thing. So if you go on the screen here, you can add, we have a bunch of symbols here that you can add to the screen. So on the faceplate, sometimes you're gonna have buttons, so you can pick a button that you may want to use. You have switches, you have sliders, so to show the slider, or you can build your own. So let's say for a PID interface, you put a rectangle for the set point, and then you're gonna add the a bar graph for it. So you can add colors to it. So the foreground color, you can even put some effects on it. And then for the original rectangle, you put some other effects as well. So, and then you associate that with one specific variable. So we were talking about the temperature. So that's going to be the current value, and then you add the set point and another one for the output. So you can also create this as a symbol. So here you're going to put a tag for the temperature. Here you're going to put a tag for the set point, and here you're gonna put a tag for the output, and then you go ahead and create a linked symbol for it. So you right click, you create a linked symbol, you give it a name, let's say PID faceplate. So that's my symbol. Okay, so I open it, and then I can just replace the properties that I created by tags that I use on my project, and I can use this as many times as I want, in as many screens as I want. And if I modify, let's say I'm gonna modify this, right click, edit the link symbol. So I'm gonna do something very easy to see. So if I go here on the rectangle and change the field, instead of blue, I'm gonna have green. So we can see this specific rectangle with green. As I save it, I just save the master symbol, and everywhere where I'm using that symbol, that was modified. So you create just once the faceplate, let's say, and you can reuse it in all your project. Okay. I've got a question here. What driver do you use, and what speed and amount of tags? So the drivers on the list that we have here, I have about 200 communication drivers, and depending on the protocol and depending on the network, you can achieve very good communication speeds. So for instance, with Beckhoff TwinCat, we can read every 20 milliseconds. With the RTP, we can get a reading every 30 or so milliseconds, and that's, you know, per group. And since we have the parallel communications, you can have several groups being read at the same time. So the drivers that we use, you know, all of this here. In the case of the Brookhaven specifically, he's using the RTP driver. I don't know if you're using any other driver, Patrick.
Well, we're certainly the big one for us is the CRISP driver, to, you know, which actually goes right into our DCS, and that's the one that we can achieve a sustained throughput of about 35,000 tags, and that I actually demonstrated a few years ago. You know, the machines, and actually we've done network upgrades since then. You know, lower latency on the switches and stuff that we have now. So it could probably even go higher than that, but we don't need it to. But if we needed to, we probably could go higher. But 35,000 tags per second, and that's exclusive of the other drivers that we use, the RTP driver, or the OPC client. So yeah, that's pretty good. That's pretty good throughput.
Right.
So you know, and that's taking place on multiple servers also. So you know, when we talk about, say, 35,000 tags per second, we're doing that not just on one InduSoft server into one you know, DCS. We're talking about, you know, multiple SCADA servers hitting on that DCS. So, you know, inbound on the DCS, the database access server is quite busy. It's actually the busiest process on the DCS. You know, it's handling all of the callers out in the field, you know, the InduSoft servers. So, but it worked it works very well. And our DCS is the alpha servers. Like I said, we're talking about 12,000 I/O points on those, with multiple, InduSoft thick clients hitting on them with the CRISP driver. And I mean, there's a lot going on in the DCSs, and the active one is typically running at 9 to 10%, utilization. So, which is good. We want all of those processes to operate freely and not be hindered by a real busy CPU. So I hope that that answers the participant's question.
Yes, and I just like to add to what you're saying. You mentioned use the CRISP driver. That's one example of how flexible InduSoft as a company can be, and as a product we can offer. That driver you don't have on our website for downloading. We came up with a special agreement with Salem and CRISP Automation to have that driver. So customers like Brookhaven, they can use that driver, and we have agreement with other OEMs as well with specific drivers only for them. And so on the top of the 200 plus drivers that we offer freely on the product, we still develop some specific things for specific applications, like we have with Brookhaven Labs there. I hope that that adds to the answer to the question. Okay, any other questions, gentlemen, ladies? Right, okay. All right. So I really hope you can make it to the training. The user that said that he may want to come here to the training in Austin. I hope to see you. And with that, since we don't have any other specific questions, I want to show you guys this slide on how to contact InduSoft. As I mentioned again, this presentation is being recorded. You'll be able to watch it from our website very shortly. And with the invitation for the webinar, you're probably gonna get also another email with the with a short survey. We would love to hear from you guys how we are doing. And if you fill in the survey, you're gonna get one of our t-shirts from our webinar series. Okay, so keep that in mind. And we're having other webinars. We've been doing that almost every other week. Stay tuned for the next ones. I would love to see you guys on the next webinars. And thank you all. And I thank a very special thank to you, Patrick, all the work you've been putting on using InduSoft, as well as on this specific webinar. You did a great presentation. I love to learn a lot that I did on your presentation. Thank you very much for that.
Sure, my pleasure.
Okay.
Thanks for having me.
All right. So with that, I'd like to thank you all and wish you guys a very good day. If you still have your day ahead, and a very good evening for everyone. And I hope to see you guys again on our next webinar. All right. Thank you.
Thanks, Andre.
Thank you.